Hello, everyone. Thank you for joining us today. My name is Mike Shelton. I am the Director of Demand Generation here at Seemplicity, and I will be your moderator today. We have a very exciting topic for our discussion today, which is from attack surface discovery to remediation, an AI-driven approach to exposure management. And our speakers are Kevin Hare, Senior Solutions Architect at Censys, and Tomer Yanovich, the Vice President of Product Management here at Seemplicity. So without further ado, I will turn it over to you gentlemen. Let you introduce yourselves a little bit more and we can get going. Why don't we start with you, Kevin?
Yeah. Thank you everyone for attending this. I hope it's useful information. I'm on the Censys side, and we'll quickly go through who Censys is. But I'm really excited to be here, and if there are any questions that pop up, please fire them at us. Over to you, Tomer.
Thank you, Kevin. Hey guys, pleasure to have you with us. I'm Tomer. Been in the cyberspace for kind of 20 years. So we'll talk about exactly what you see here, the attack surface discovery to remediation, and see how Censys and Seemplicity are integrating together to achieve a very interesting use case.
Cool. Mike?
Right. Kevin, you want to get going?
Yeah, I'll just start.
Perfect.
So for those of you who don't know who Censys is, our mission statement is to be the place to understand everything on the internet. So what does that mean? We scan the entire internet on a cadence of every single day, so about 24 hours, but we're scanning constantly, and we identify any public-facing assets across the whole internet infrastructure. And not only that, but we query every single port on the 64K range. We test them for over 200 different protocols. We're port agnostic in that regard. And then we index every data element and pull that data into effectively the data lake. So about 4,000 discrete elements of information. And the result is that we end up with a scanned internet with a really, think of it as a very deep digital map of the internet. So automatic protocol detection, multi-perspective across 3 different continents. And we also, every time we touch an asset, we snapshot that asset, and we have those snapshots. We ourselves have them going back about 8 years, but many of our customers are using anywhere between 1 month through to about 2 years of historical context. So you can go back and find out when a service showed up. You can go back and look and when a particular asset was talking to your infrastructure and see what that asset looked like at that particular moment in time. That data, and this is basically just a recap of that information, you can see that we're sitting at around 20 petabytes of data. We also have threat insights and the world's largest certificate archive, about 17 billion certificates, but that keeps adding every single day as we discover new assets. This is basically what platform looks like. We've got search, threat hunting, and attack surface management. So from the attack surface management perspective, we're basically running an attribution engine against the backend data lake, pulling all the data that matches up with that organization into the attack surface. And we end up, and I'll share my screen here, and I'll just do this briefly. We end up with a map of the attack surface. We'll show you where they are geographically. We'll show you the hosts that we find, the domains, the web entities, and the risk. And that's really where Seemplicity comes into play. Because when you think about it, one of the issues with, and let me just, can I start? Oh, then end screen share. One of the issues with identifying risk is that in many cases, that risk has been sitting there for quite some time. That risk has been largely ignored, or basically nobody knows who owns that asset. And so I'm really excited with Seemplicity because from my perspective, it continues the flow from data discovery through to building an attack surface, to showing the risk, and then taking that risk and mapping even further information such as ownership and so on. So I think, Tomer, if you take over at this point.
Thank you very much, Kevin. All right. So, kind of following up on what Kevin said, we have to have good context. I mean, without the context and without the data, I mean, you're just going to find yourself working on either kind of the wrong things or maybe even fixing things incorrectly. And basically, you're going to be very inefficient in the time that your organization spends on remediation because maybe you're just not remediating the right things. And it might be because, again, you don't have the right context to make the decision and say which one of these findings that I'm getting from Censys, for example, is the one that has the most likelihood to make the biggest impact in my environment. So the way Seemplicity it takes this data and kind of to put everything in perspective for everyone, you see this kind of workflow over here because eventually you need to take all those information that you have and you need to start putting it into a process, into a workflow, one that is tailored to your organization's both structure and the way how you want to measure and monitor your business units, and also in the way how your teams are remediating. And in addition to that, you also need to make sure that the policies that your organization has set, for example, what is considered a P1, what is SLA that's maybe a 5-day to fix a critical. So all those things are going to be policies that every organization has tailored for itself. So we need to make sure that we can customize everything to adjust to the customer environment, workflows, and policies. So the way that will work is we will digest that information that we're getting, and to really build a comprehensive picture, it's not just about getting a list of findings. We need a lot of other context, such as kind of different threat intelligence to tell us about the severity, impact, the exploitability. It will be an EPSS, it will be CISA, VANCheck, things like that. And also understand, of course, where is that asset in the environment? And more importantly, what kind of compensating security controls are in place that already maybe perhaps prevent exploitation of some of the findings that reside on a machine. So the context both in defining the way that it can exploitable impact, and also for the resource to understand its surrounding, and whether that's, of course, a business critical asset for the organization, and if that asset is exposed. This is critical context that we will need to get from all those tools. And this is the signal collection here that you see in that left circle. So we will take all these different signals and together put them together into this coherent picture that will allow us to make a decision based on the policies that soon I will show in the product. We will prioritize this list, and then the part that we help to complement a lot of those tools is the mobilization part. The mobilization means how am I getting this finding to the right fixer in the right tool. So for example, if I have a finding that needs to get a certain person, let's say in a Jira ticket system, I need to know that this finding needs to be redirected to that person in Jira in the correct instance, in the correct project, to the correct person. Another thing we also need to mention is this whole process needs to be something that, of course, does not create any additional friction between the security engineers and the fixers. So there needs to be some kind of agreement on the format of the ticket and all the data that the context that we provide for the fixers to help them fix as fast as possible. So that's one thing. Also, we need to make sure that we're not bombarding these guys with tickets, and again, just kind of overwhelming them with all the amount of work that they have to do. So all that stuff needs to be kind of carefully attended. If we look at the AI agents, and you probably hear about this, in every presentation that you see, but let's kind of look at why do we have this thing. So the way we can get the extra benefits from AI, I mean, it can benefit both, the protectors, and also it benefits the attackers as well. So it's kind of again of a race as who's leveraging this technology, in the best way possible to gain the upper hand. So the way, and we'll show this in the product in a couple of moments, we leverage that in Simplicity, is also to provide the clarity, to provide insights about different compound signals that maybe it would be difficult, of course, for someone to correlate all these different data points and come up to some kind of an insight and call to action. The way of finding the fixer, this needs to be a mechanism to really find the fixer, because the fixer is not always in the same place in the same tool. Fixers can be spread all over in different tools, and fixers can also change over time. So that is a constant thing that we need to make sure that we help our users with. The remediation part, as mentioned, this helps us to understand where to redirect this finding. And of course, we want to make sure everything is an automated process, because eventually the goal is to help fix problems as fast as possible with the least amount of manual human intervention. And eventually also help with providing a contextual ticket that fixers can fix very quickly, and that will reduce the MTTR of fixing issues. So we're all about kind of remediation efficiency in this meeting. I'll show you also with the AI assistant, and really kind of what breaking kind of the barriers, both in terms of use cases that can be achieved, and also in the way you interact with the system, because you no longer have to be an expert in every tool. You don't have to understand the data model and how everything was structured. You can just use the natural language as understand security, and start to ask questions to understand better how your security posture and all different kind of areas. And eventually, what we're kind of here to tell you that one cannot live without the other, right? So we can do the mobilization, but we need to make sure that we have good data, one that we can rely on, that provide a lot of context, because this context is what helps us make decision when we want to mobilize the data. So this is why this integration is very, very crucial on both ends. And I think we can kind of jump kind of straight to the product itself. So let me just share my screen. All right. So I'll start with this. As you go into the Simplicity platform, and we're going to cover all these different use cases here. One of the use cases, of course, is that you want to get the ability to monitor your security posture. And when you have Simplicity in your environment, Simplicity is the go-to tool to understand your security posture, because, again, we integrate with all the data sources and bring all the data into one place. So you don't have to go through different systems and start to connect the dots to try and understand security posture. You're going to go into one place and have that understanding. With using AI, what we've done here is we've built insights that will allow high-level security persons, such as a CISO or anyone of that matter, to really kind of get an understanding very quickly by getting a few matrix, and again, in a simple language that kind of takes all these graphs and everything, kind of narrow it down and provide the gist about what it means to understand security posture. So we would give, using the AI, two matrix here that present what we call the good KPIs. So you can see here in my demo environment, of course, the strong SLA compliance. We can see over here, a lot of things are on time. Here with the Censys, I don't have any P1s, which is again great. And we will provide also two things which are not as good. Okay? That will usually require someone's attention and needs to be maintained. So this will be one of the things to cover the security posture. Of course, we also have the dashboards where you can tailor your own dashboards and create the widgets to get the perspective that you want. But let's take a look a little bit at what's happening. As you plug in the Censys integration, and here you can see that I'm looking at the Censys information, you will see all the findings that the Censys is providing us with. You can see the different details over here that they give you the context, and of course you can drill down inside. And inside you will find some more information. And then you've seen our AI, what it's doing is formatting the data in the Markdown language to make sure it's readable. And you can see here that the SLA status, you can of course change your status, priority, which we'll discuss in a moment how this is given. And here we also have at the bottom some more information about the package that the finding is relevant for, and all different kind of enrichment that we're providing on top of the finding. So this will be additional threat intelligence sources that we connect with. So you can see the vuln checks again, as mentioned, the EPSS to provide us with a more threat intel context to decide to make a decision on how severe this finding is and how we should prioritize it. With the AI, also what we're able to do is we're able to generate remediation steps. And this kind of really gives you a playbook, a play-by-play of how you should fix the specific finding. Because again, not everybody is an expert, and this is giving you the exact commands and the exact steps that you should execute on the specific tool relevant for the finding. As mentioned, we know that this finding resides on this resource, again, coming from Censys. So if we're going to click on that, we're going to get some more details on the Censys resource. And you can see that we have some tags here. This is context that we can pull also from the Censys side. So we got the exposure, we got the public IP, we got this information. And the way that this is useful is, now imagine, of course, that you're getting a lot of different sources of data in here. So if I'll just clear this filter over here, so I'm going to get all different kind of sources that Seemplicity have put in here. So I've got data coming from these 4 different data sources. Now, as mentioned, when you look at the findings, you don't just look at a huge pile of findings. Now it's time to start thinking about how you need to segment the data, in both in terms, as mentioned, how your organization structures and how you want also to distinguish between machines which are more severe because, again, they might be exposed to the internet, or maybe you want to look at things from business line manager perspective, or it could be from a product security, it could be offices. Whatever perspective you have on the data that is tied to your organization and how you want to kind of slice and dice it in terms of, again, having that workflow towards remediation, or for the use case of having security posture and the ability to monitor specific business units on their own, or specific people for that matter. This is where we create what we call the scope, and we basically segment the resources across these different scopes. All right. So here I was able to look at the ones that the internet exposed, and this will be everything over here. Now, one thing to kind of maybe just mention over here, the way that this can be achieved is also just click over here. We can also build that out. We have smart tags, again, that we're using AI, and the way we do that, we take all the tags that we gather, and what we do then, we group the tags together by their meaning. So you will see, for example, tags that, what were those? Some tags that have been grouped together. So we clean those out, and making sure that we provide only with the contextual tags here to help you automatically build out those scope hierarchies. So this is just kind of one thing to mention over here. Now, once you've integrated all the different data sources, you got the information as we've shown from the Censys. Now you would think about how you would create all your different policies. So creating the policies mean that you want to define what is a P0, what is a P1, what is a P2. You need to create your own ladder. And you need to make sure that you're very specific about it. It's not just about kind of vague security scores that you really don't understand how they're composed. It's about really hard-coded attributes that you can define and decide what's the priority for your findings. So with that, we've got that over here. Now, another thing that will happen as well is, for simplicity, we'll also aggregate similar findings by things that have, for example, the same fix. Because if something can be fixed once, for example, I have a log4j package that needs to be patched and fixed, that means I can potentially fix maybe 100 problems just by fixing it in one place. So this is exactly what our aggregation mechanism is doing. It takes findings that have the same fix and aggregates them into a single finding. So you can basically, kind of kill 100 birds with one stone, let's say. For the automation piece, and this is basically the mobilization part. And as we mentioned, we want to make sure that we can automate everything. We don't want to have people manually need to open tickets, although again, that can be an ad hoc scenario, but we want to make sure everything is automated. So here, this is what we're going to take, as mentioned, a scope, which is a set of resources, a filter, which is a set of findings, and basically I'm going to say which team does this represent, and I'm going to start streaming different tickets to those teams. And basically those queues, what they're going to do, they're going to have a waiting list that's going to open tickets. And as mentioned in simplicity, we know how to limit the number of tickets that are opened at a certain period. So, because again, we don't want to overwhelm the people on the other side, the fixers. We want to make sure the process is again agreed upon and maintained carefully. And every time there's new capacity, we will start opening tickets, and those tickets, of course, will get in the hands of the fixers. Last piece, I think, it's very interesting to cover here. We just released our AI chat agent, Sima. And Sima basically kind of spans across the entire simplicity data. So the great thing about it is you're not kind of bound to the guardrails of the UI or the way the data is modeled and structured. So you're not just asking about a specific use case at a time. So it's not just about findings, not just about the resources, not just automation policies. You can ask about everything at once, and you can ask, of course, complex questions that span across multiple entities together. So just in here, I had many questions I asked Sima over here about resource owners. Let's show something like this. Here I had a question: how well is my team meeting SLA? So Sima provided me with SLA performance matrix and showed me a broken graph here by priority. So I could see it, and then I get key takeaways that explain exactly the percentage of findings, again, that had the almost broken SLA. So that's kind of one example. Riskiest asset report, also here another question, show me my riskiest assets, pretty basic, common question, I would say. And here you get a list of those assets, and of course with the context of the provider, you get the link that you can click, of course, and go visit that asset, and you get, of course, other information here that's again, relevant for that with that key takeaways. So really interesting questions, and you can see another common one is again, am I affected by log4j vulnerabilities? And yes, and this is the list of findings. And again, this is clickable. So basically, here what we wanted to achieve, because we have so many different type of customers asking so many different type of questions, because we span across different industries and and also small companies, bigger companies, smaller teams, larger teams. So really, having this tool was super important for us to say. As it starts working, of course, we'll show the reasoning and provide exactly, it's going to explain what it's doing to give some more credibility to the results for that. And that is about that. Any questions from anybody or that matter? Yeah, and here I get my list, of course, of exploiting the wild. Yeah.
All right. Well, thank you very much, gentlemen. Anything else you wanted to cover in today's topic?
No, I think for my end, I'll just kind of emphasize that, again, if we're talking about exposure management platforms, it's I think the reason we're kind of hearing that term more and more these days, it's again because it's not just about bringing findings from all over the place and just bringing as much data as possible. I think everybody understands that it's pretty much impossible to start to even try and deal with all these amount of findings. And over time, we've seen the evolution of prioritization and rescoring and everything, but what we're seeing today, I think, with people getting more of threat intel information, getting more understanding of the asset and its context, getting more understanding of the environment and security controls already in place. I mean, all this is context that you need to have in order to really have an exposure management platform to make the best sound decision that you can have, because you've made sure to bring all these data points together to provide it with a comprehensive picture and really make sure that you remediate what matters the most. Because again, like, code is changing so fast, and especially now with AI, I mean, everybody's kind of spitting out new code so fast. So, and we know that as much as we want, and people are starting to implement, even security guardrails inside the code or security inspections, while as they're writing code. We know that the business will always still continue to move faster than security. So when those security issues do reach the real world environment, which we should call it that way, it needs to understand how that real world looks like and how the attack paths can actually be leveraged in that world, because the finding is no longer living in the staging environment or again in the QA environment and in the repository. It's now out in the real world. So there's all different kind of environment variables. There's all different kind of network connections. There's the cloud infrastructure and the way that was set up. So all that context is something that really needs to be understood, because the way finding is the context that it has while it's in the repository and while it's in the real world. Those can be two different things, and which can really change the decision whether it needs to be remediated now or whether it can be remediated later, because again, it might be mitigated by the controls or things like that. So yeah, I think very, very important to kind of put some perspective into the world that we're in today, and how really to create this machine that kind of never stops fixing and moving things, of course, from the discovery world to kind of the triaging and putting all those information dots together, and of course finishing up with mobilization, validating, of course, the correct fixes, and on top of that having the way to govern that and have this ability to report and see security posture, of course, matrix and measure yourself to see if your remediation program is efficient or not. At the end of the day, that's what's important.
Okay, and we have a good question from one of our audience members. So the question is, how heavy of a lift is an integration like this, connecting a solution like Censys to Seemplicity?
Mm-hmm. So I think we can even kind of show the small amount of data that's needed.
Yeah.
Sure.
I think the API call is very lightweight and it just pulls the risk instances in.
Yeah, and I'll just share here for a moment again, just to show that. So very easy. Let me just backtrack for a bit to see how I got here. So in Seemplicity, we have the data sources. This is basically all the integration that we have, pretty much growing by the day, we can say so. We have about 158. So if I'm looking from all those different categories over here, so if I'm looking at the census, you can see I have one over here. I can also, of course, add a new one. And basically, just name it, give the API key, and you're good to go. I mean, that's as easy as it gets. Again, you get the permission from the Censys side, you get the API key, and that's it. And yeah, data will start flowing whenever you schedule it, or if you want to run it now. That's it.
Very nice. Very good. All right. Well, I think that wraps up the topic. Very well done, gentlemen. I just want to say thank you to our audience members for joining us this afternoon. And we will, of course, send everybody a recording of this discussion. You can share it with whoever you'd like. And if you have any follow-up questions, please reach out to us, both at Censys or at Seemplicity, and we will absolutely follow up with you guys. So thank you, gentlemen, for your time. Appreciate it, and have a great rest of the day.
Anytime. Thanks, guys.
Thanks, Tom.
See you.